So till now we have discussed about the classification technique of the KNN. So in this lecture we will simply learn how these classifications techniques will extend it to a regression technique. So to before getting this concept we have to know what is the main difference between classifications and regressions. So let's go. Oh, suppose let's take we are interested to classify our datasets in two class classifications. In two class classification. Then what will be look like of our dataset? So our datasets will be look like this type. So D, let's take D is our datasets and data point is I and YI. I is 1 to n. Suppose let's take our number of data points in our data sets D is n. So data points are look like this. We have already seen this structure. Here x is called our features vector and y is called our corresponding output of this features vector. Such that we have seen if we have considered our features vector are in a d-dimensional space, so x belongs to Rd and corresponding yi is simple our class level. Simple here we are considering two class classifications. So our one class is let's take 0, another class is let's take 1. So this is simple our classifications data set. If we simply consider the two class classifications and what are doing actually in KNN. In KNN we are going to doing we are find the k nearest neighbor points and according to its majority vote we have decided our output of the corresponding query point. So in KNN we are first find the k nearest point. K is simply your hyperparameter here in our k nearest neighbor algorithm. According to our chosen k we are find the k nearest point and on this k nearest point we are find its majority vote, and based on this majority vote we are decided what will be our output of what would be the output of our query point. So simple we are constructing a functions f such like that our f of x cube give an output y cube, and simple this yq it's actually our belongs to a class level. Class levels means here we have taken 0 1 1, so simple it belongs to our class level. This is simple classification technique till now we are doing. So what is actually the regression technique? Suppose let's take our instead of here I am taking the class level. If you just interest to find the height of a person's, so height of a person's is not a integer kind of thing, it is a real number. So in such scenario classifications algorithm is not useful. So let's take how it should look like. Suppose let's take for regressions our data sets look like D, that is using green color, and our query vector is xi, corresponding output is yi. Similar thing our number of data sets is n, but here similarly we have features vector is belongs to d-dimensional space and corresponding output here is not the class level. Here corresponding output is belongs to a real number. A real number. So in such scenario, in such cases, if our corresponding output is a real number, so in such cases, with this technique is called the regression technique. Regression technique. Okay, and if our output is simply a integer means or simple it is denoted by class level. If our output is a class level, this is simple the classification technique. And if it is real number, the main difference is that nothing else, everything is same, but the difference is our output, corresponding output. In classifications we are given output is corresponding class levels, but in regressions it's a real number. So here we are finding interest to find a functions. Here we are interested to find a functions f or a query point. It gives us output yq, which belongs to a real number, not a integer number. Okay, this is the main difference between classifications and regressions. Now let's see how in knn is useful in regression. So what are doing, let's rewrite this thing one by one. What are doing in knn? Suppose let's take in first we are given, we have suppose let's take we will give a query point xq. Suppose we will have a query point xq and interest to find its corresponding output for the k nearest neighbor algorithm. So given xq, we are interested to find into k nearest neighbor. Okay, as first we have doing this job in knn. So suppose let's take our knn point is like that. Suppose let's take our knn points is x1 y1 x2 y2. So let's take x k yk. That's k points is our the knn point in for a given query point x. Let's take, but one thing here yi here is yi. One thing you have to mention, we have to remember that here yi is not our class level. Here yi is simply a real number. Okay, here I is going from 1 2 3 up to k. Simple. So what are doing here, we are just deciding the majority vote in class level because yi is belongs to simple class levels. According to that, we have decided what is the majority vote. But if it is in real number, how will decided which number is majority? Because it is a real number, it is impossible. So what are doing here? So actually we are doing in the classifications. In classifications we are doing just find the majority vote. We are simple finding the majority vote, but here we are not finding. Here just simple technique we have adapted. So in step 2 we are finding the mean of the y vector. So our yq will be coming from these sets, means yi y1 y2 y3 dot up to yk. We have to decide our y query point or yq, means query point of our required point xq. Its class level is its output will be yq, and we have to decide it from these points, that is y1 y2 y3 up to yk. But it's not a, but the main thing is you have to remember, these points not 0 or 1, means it's not a class level, it's simply integer value, so in such cases we have decided, we have taken here, we have taken the class, we have decided our class level is simple mean of this i's. Yeah, I is from 1 to, this is simple technique. Or if we just omitted the outlier concept, if we just not interest to take the outlier, if it is not interest to take the your algorithm more outlier form, so then we are using here median. This is the simplest regression technique, and also there are many kind of technique to decide our output, but these one are the simplest. This is the one, the simplest one, equals to 1 to k, and this one I is equals to 1 to k is more prone to, this one is more less prone to outliers. this less point over outliers. Though this regression technique is the simplest, this is the simple extension, simplest. Simplest extension, this one. I think you will understand how to extend this simple concept, how to simply we have extend this concept from classifications to regressions. So this is there have various techniques to extensions of classification to regressions, but among these I think this is the simplest one. I think you have understand the motto of this, how to convert, how the regressions work for classifications, how we are choosing a classification algorithms, and how to extend the simple classifications algorithm to a regressions algorithm. You have, I think, you have learned from these lectures. Okay, so we'll see in next lecture.